Welcome to React Workshop, the next level. Today's event is brought to you by CougarCS. My name is Nykolas Farhangi. I am the Director of Tutoring at CougarCS. Some of you may know me from the Tutoring Discord channel. I'm on there pretty frequently. And today I am hosting this event with a couple of my friends, Shubh and Hasan.
Hey guys, I'm Shubh. I'm Webmaster at CougarCS.
And I'm Hasan. I'm a web developer at CougarCS. And yeah, thanks for having us here.
Yeah, absolutely. So right here we have, oh, my bad. On the slide before, we have our LinkedIns and socials. So feel free to connect with us and follow us, follow our GitHubs. But without further ado, let's go ahead and hop into the event. So for today, our goal is to take you beyond just the basics of React. We want to walk you through some of React's core concepts and show you all of its functionality under the hood. So we'll start this event off by giving you an introduction, kind of a refresher on what React is and why you should use it, what's so cool about it, its differences between other frameworks, before we hop into a deeper look. And this is where we'll lift up the hood and take a look at how React works component-wise. As we wrap up this event, we will share some of our favorite Node.js libraries, some of our top picks, and then give you some recommendations on developer tools that can assist your development cycle. And lastly, we'll share some useful links and resources. This will just be some further reading, some YouTube videos, and some projects you can try yourself. So if you guys enjoy this workshop, you can go ahead and pick up where this leads off with those links. Now, without further ado, let's go ahead and hop into this event. I'll go ahead and pass it off to Hasan.
All right, thanks for that, Nykolas. If anything, yeah, let's start. So let's start with React, what it is. It's an open source JavaScript library used in the front end of websites or web apps. React can be used as a single page base in web dev or app development, and it's also maintained by Facebook. All right, so here is an example of some React code, and clearly you can see it's almost impossible to not get a syntax error on the first try. There you go. But the second time, it's going to import the logo that we wanted to import, and there, it's functional. All right, so here's some advantages. It's easy to learn and use. You can create dynamic apps more efficiently. It promotes code reusability. That's going to be a key concept in this PowerPoint. It also employs a virtual DOM. Let me get into what a DOM is. So a DOM is a document object model. And basically, you can consider a web page as a document. The document can be displayed in the browser window as a HTML source, and it can also be displayed as the DOM. The DOM is just, it can be manipulated by the JavaScript. So ReactJS uses the DOM to fill in data on the HTML, and the DOM works fast because you're only making changes to the virtual component, which is essentially a copy of the actual DOM, but it just re-renders it. So another thing is there are a lot of free third-party dependencies and libraries, and it's good for testing with good documentation as well. There's some disadvantages, but then again, you can overcome these things because the environment continuously changes. It really depends on you as you're with your skills in JavaScript and HTML. The more you know JavaScript, the more you can keep up with HTML and all these combined. You should be able to change with the environment. Just keep on doing more projects. ReactJS it really covers the UI layer. So you may need something for the backend as well, like Node. But then again, there are plenty of libraries out there. And React does use JSX. So the only downfall here is that when you're mixing those two together, you may either know HTML well enough or you may know JavaScript well enough. But if you can pick up on both of them together, this disadvantage can really turn into an advantage. So let's go to the next one. So as you can see here, this is a graph from Stack Overflow. Given the fact that us as programmers, my apologies, us as programmers, whenever we get stuck, that's really the first place to go to for any type of questions we have. So you can see React slowly rose above Angular after 2019 in terms of questions, and thus help build an extensive form full of solutions that you can use on your project.
Right, and this is maybe a factor in why you guys might want to use React over another language. This is not to say that Angular and Vue aren't popular, but what this graph represents are the percentage of Stack Overflow questions like per month that are of one of these frameworks. So what's really cool here is that you can see React has been continually growing in popularity, while a framework which has been traditionally very popular like Angular is slowly falling off. And now this isn't a bad thing. These both have extensive documentation, but one thing that you can extrapolate from this graph is that the language or framework that you want to be using something that has an active developer community. And what I mean by that is I don't just mean a developer community that is constantly rolling out updates to the language, but also a developer community that's asking questions online. I don't know how many of you guys have been out there. You're stuck on a weird problem. You're getting a weird error, and you Google like, how do I solve this like exact error message? And then there you go. You find like 6 Stack Overflow articles with people, asking the same question, and you can very quickly, just copy paste someone's code and, plug it into your thing, and there you go. Your error is resolved. The reason I mentioned this is, I mean, that's practically, I kind of just told you guys how I string together my React applications or my applications in general is just like a Frankenstein of Stack Overflow and other people coming with good solutions. But definitely a factor you want to consider when choosing a framework is what is something that has a good developer community that you can find help online for, find help online for easily and timely. So yeah, React is definitely growing in popularity. It's a great language, so definitely something to keep in mind here.
Absolutely. So as you can see, there's a lot of large name companies that use React on their applications and websites as well, like some notable ones like Tesla, Salesforce. God, this is why you should have your phone silent. And WhatsApp and stuff like that. So it's definitely advantageous if you want to put ReactJS on your resume. You can definitely get picked up by these companies.
Yeah, absolutely. All right, cool. So thank you, Hasan, for that introduction. Let's go ahead and hop into the meat and bones of today's workshop. This over here, we're going to be breaking down React into its building blocks and hopefully teach you guys some good like practices along the way. So the basic building blocks of any React application are its components. React applications are essentially an assortment of these components, and each component has its own logic and rules that, in addition to its own subcomponents. So when you break a React application to components, think about it like this. A good way to understand it is each component is responsible for a subset of the functionality of that application. So what I mean by this is here we have an example project that I worked on in the past. And on the right side, you can see the React components that make up this website. We have the app, which is the root component. It's the parent of everything else. And it has a toolbar and an account viewer right beneath it. So think about it like this. My app is responsible for the entire application. This is like, in a sense, the driver. This is the canvas which everything is put inside of. And then it's built out of, its children components, which are, the toolbar and the account controller. The account controller component is responsible for the subset of functionality that has all to do with, your account. So managing the user signing in or, creating an account. Or, once they are signed in, you want to show a different card here that, has their, login information like, welcome so-and-so. So it basically contains everything that's related to the account logic. And then we have the toolbar, and this is just basically has some buttons, and it controls all the logic regarding switching between these different tools. So this is just to kind of set the frame of reference that in React, your entire application can be broken into subcomponents that each carry their own subset of responsibilities within the entire application. So in React, React represents these components as functions. This has become the standard practice. So if you can click really quick, yeah. So functions are components. Are JavaScript? Function components are JavaScript functions, just regular JavaScript functions that return a React component. So you can see on the right side, I have this return statement. And with this returning, this basically is returning an avatar image that has the source from the props. It basically grabs it from this props. It says, grab the URL, grab the alternate, message. Now, to some of you guys who have a little bit of familiar with web development, you might think that this is HTML, but that's where you would be wrong. This is using a special form of JavaScript called JSX. I'm not exactly sure what that stands for, but what it is a hybrid of JavaScript and HTML. And you can notice the subtle differences in, for example, the class. In traditional HTML, you would just say class equals, class name, as opposed to class, camel case, name equals avatar. So that's kind of a tell that you're looking at JSX instead of HTML. Cool. So your function should aim to be small and only responsible for one task. So going back to what I said on the previous slide about each function represents a subset of responsibilities in the application. You wanna make sure your functions are like limited in scope. A common anti-pattern, and what I mean by anti-pattern is something that can set you back, like negative progress. A common anti-pattern in React development, or in actually programming in general, is making these massive functions that handle a whole host of things that that like have a whole list of responsibilities, and the function is dependent on a whole bunch of other things. What this can lead to is a tangled web of dependencies that can honestly create a hell for a developer if they need to do any restructuring or trying to clean their code or move things around. It can become very, very tedious if you have like complex functions that are responsible for a lot of things. So a good practice is to make sure that your functions are small and limited in scope. For example, here on the right, we have an avatar, and the only thing it's doing is it's returning a render for an avatar. It receives the avatar information in the form of props as an argument, and then it uses that information to make a render, which is return that image. So you want to use your functions to divide and encapsulate your logic into these modular reusable segments. And as Hasan touched on in the introduction, a really big theme here in React is to write less code and do more with less code. And you do this through modularity, through reusability. You want to make your code generic and like as reusable as possible, like we're convenient, practically speaking. But moving on. Here I have an example, and what I'm going to do is walk through and break this down into its React components. So we have this big yellow outline, and this encapsulates our main component. Like think about this as the app. This is the root component, and the app this has everything inside of it. The app is going to be divided into two categories by functionality. We have our search bar at the top, and I want to basically I have a search component at the top, and this is what I want to use to contain all the logic that pertains to my search. So I have the search bar itself, and then like a qualifier, show only products in stock. So basically, any logic that's related to the search, I want to contain within this one search component. And this is going to make it easier for me to manage, like in the long run, because I have an app, and then I have my individual search component. Next, I have this green outline, and this represents my product container. And it has column titles at the top, one for name, one for price. And what this products container is holding onto is a list of these products. And here we see that every single product has a name field and a price. So what React lets us do is break these components, this list into individual components. So I have this product component, which has two values, a name and a price. And what React lets me do is basically reuse this code for a product component. So instead of like having a bunch of HTML code, one for football and the price, and then the next one for baseball, next one for basketball, what I can do is have a single piece of code that receives a name and a price, and then outputs returns this render, which has this row here. And then if I have like a list of these things, like a list of products, like a list of football, baseball, basketball, I can then say for each item in this list, render it using this render logic. So this is where React becomes really powerful. And, this is another sense of reusability, in this product component. So Now that we kind of have an idea of how how we would go around and go about breaking up a React component, let's go ahead and take a look at the next slide. Here is something from an application that I made, and I kind of want to query the audience. I want to see, get some opinions. How would you guys go about breaking up this component? How would you guys represent this? Like, what would be the major components? I'm gonna wait just a moment. Feel free to unmute yourselves if you have an answer. There's no wrong answers here, guys. So this is totally by opinion. There isn't like a right answer here. So I'm kind of curious. What do you guys think?
I'd say the button can be its own component in the class names.
Yeah, like for sure. That's a great point. Like, yeah, the button we can use this button to, like, anything that's related to any actions that are related to this button, we can encapsulate in its own component. So like, let's say the button has some, a bunch of functionality like behind it. If you don't want it to be like all condensed, you have like some mega function with a bunch of complex stuff in here, you can just rip out the button and make it its own component. And yeah, so here I kind of outlined what this would look like, how I would break it down. We have the semester, which is its own component, the big green square that surrounds it. Kind of think about like this is the main component, the root. Of course, you want to keep in mind that we are just looking at this by itself. So if you are in the context of the entire application as a whole, there would be your app, and then your semester would be a subcomponent of the app. Now, the semester has its own subcomponents, which are the course. So we have some sort of course subcomponent which receives the inputs, the course name, the credit hours, and the letter grade. And instead of me writing out this piece of HTML code for every single one of these, I can just write one React component and then iterate through this in a list. So let's go ahead and take a look at let's go ahead and move on to React hooks. Now, this is another big concept in React. Historically, in React, historically, you would use classes to represent components, but React recently introduced this new feature in 2018, and it has since become a standard practice. And what's really awesome about React in general, and not just limited to this, is React has a huge focus on backwards compatibility. When they roll out some new features, they don't just go and deprecate everything that's been used in the past, and then a bunch of angry developers need to go through and update their code to the new standard. React keeps most of their new features backwards compatible. So what's great about hooks is this is totally opt-in. This is not something you would have to do by choice. And what Reacts let you do is their functions, or is it what hooks let you do are their functions that let you hook React state and lifecycle features into your function components. So what I mean by this is a state is, in a sense, a state is like a variable that defines a component. So think about a state. Let's say I have like on the previous slide where I had that like semester thing, right? Let's say if you actually click back to that previous slide really quick. So I have this this semester card right here. Let's say I want to have two states. I want sometimes when you click on those three dots, I want it to be in like an edit mode, and then everything has like an edit. Like you can edit the text fields, you can edit the numbers and stuff. Like it basically it basically puts an edit mode on this, right? So that's one version of this. That's one state of this component is edit mode, and then another state is not edit mode, normal mode. So let's say I can represent this as a Boolean. So my component has a Boolean state in edit mode, true if it is in edit mode, false if it isn't in edit mode, and like that is the state of this component. Now, if you can hop over back to the next slide where you were at with that first sentence. What basically what this lets you do is traditionally functions don't have a state or context. Functions don't remember things about themselves. Those of you who have taken like normal computer science classes, which I'm sure many of you guys have, a function traditionally in a programming language is contextless. When you make a call to it, it doesn't have any memory. It doesn't know anything about itself. It only knows what's being passed into it, and then it does some process and returns a value based on it, right? What a hook is it lets you hook in some features like a state and lifecycle features. So if you can go ahead and click. So hooks, these let you seriously expand the capabilities of a function, and they come in two flavors. There are built-in functions. If you can click again. There are built-in hooks that React provides for you, and then there are also custom hooks. So for today's workshop, I'm only going to be discussing the two most popular built-in React hooks because they are like very significantly used, and if you guys are interested in getting serious about React development, you'll use these the most. The additional React components, you guys should definitely look in. It's not really in the scope of today's workshop, but they're good to know if you're interested in getting really technical with your React projects. But moving on. So React hooks allow you to capture the same logic with significantly less code. So here I have an example of having a stateful component, so a component that has a state. On the left, we have that traditional example. In the past, you would use a class to represent a component, and you have some boilerplate code here. You have a constructor, and the constructor, passes its input up the chain to, it's inheriting from React component, so it's supering up to the React component constructor. We have some like complicated looking code. We like say this.state, so we're accessing some state value from the React component. We're setting a default value to it. We're defining all the functions inside the constructor here with like the this.handle name change. And then below it, we actually have our functions like handle name change. And this is kind of like a handler, an event handler. So let's say someone clicks a button. I want to handle, that button click, right? So it'll say this.setState. I'm going to call the setState function that belongs to the React component above me, and I'm going to set it some target value. And then I have another render function that will go and print it out. And now to access this variable, the state that I'm defining, the name, I need to say this.state.name. Now, this looks a little complicated, and it has a lot of like extra code. It has a lot of extra weight with like this constructor and all this. I mean, frankly, like all this little junk right here. What hooks do is allow you to capture the same amount of logic, but like half the code. On the right, we have a function component. And the function component has a hook, a useState hook, which hooks in the name, this variable called name and setName. And what we're doing is we're defining the default value of that name as Mary. And now what we have is a function that has the variable name that, and it memorizes it. And then we have a function that's defined inside of this component, which is handle name change. And this will handle any events that get triggered, like if you have a button and you want to reference it. I'm not using it here. Now notice if I want to change the name, if I want to change that state, I can update it calling that function super easily. I don't have to say, this dot or whatever. And then at the bottom, when I'm rendering the component, I just have to reference name directly because think about it as a variable that we're defining the scope of this component right here. I can just reference directly as opposed to saying this.state.name. Now, this might not seem like a whole lot of code, a whole lot of complexity that it's removing, but trust me, guys, when you're making like really big React applications or like as your React application scales in difficulty, these like small quality of life changes can seriously add up in a lot less code written. So let's go ahead and take a deeper look at React's built-in hooks. So I'm going to start with useState. This is possibly one of the most commonly used. This is like the most commonly used React state. And at the top, I have this image here that kind of breaks down what's going on. I'm going to start on the right side. We call this function called useState, and it passes in a single argument, which is the initial state of the item we wish to define. On the left, this function right here, the useState, is going to return two values, a pair of values, which is the state, which is like the state itself. So you can use this to reference the value. And then a function, setState, which is used to update to the state. So like anytime you want to change the state, you want to do it by calling setState, the setState function. So you don't have to write some setState function. What you do is when you call useState, it'll return the setState function for you. So all you have to do is set up a variable that will be defined as that. So here I say constant state comma setState is equal to useState, and it defines state as the current state, my variable that I can use to read it, and then setState to update it. Now, I kind of already covered this here. Now, the reason why you have to use a function to change the value of a state is twofold. First, you'll notice that we define this as const, which means constant. So constant values are immutable. Once they're defined, they can't be changed. So, and the reason React does this is to protect the values and to ensure that whenever the state is updated, you want to trigger a DOM refresh, a DOM refresh. as Hasan defined earlier, the document object model is what it stands for. React uses a virtual document object model, and it's basically a way of representing a web page into like objects or components that are easy to understand, and then you can like make changes. You can use JavaScript to make changes on those objects. So whenever you call setState, what that does is it tells React to update the state to the new value that's passed into setState, and then React is triggered like, oh, okay, my value's been changed. Now let's go ahead and re-render the website. So this is what gives React that sense of dynamicism, and like why React is really good for making like easily dynamic websites is because whenever you change the state of an application, whenever you change the state of a component, it'll re-render the components and like the website gets refreshed. It gets like, updated. We have like a cool interactive web application. So I have an example on the next slide. To use a state, to use the hook use state, you first need to, at the top, you need to import React, which is your basic React component. You're going to use this this should be at the top of any React file. And you pass in the dependency use state, and you're pulling that from the React library as well. So keep in mind, you're not actually writing this function yourself. This is provided to you. You just import it into your application. Now I have my React component here called function example. And I'm declaring a state called counter, like a count. I have my variable count and I have my variable set count. Now, can anyone tell me what the initial value for this count is going to be? Like right when this component is first rendered, can anyone tell me what the initial value of that component would be?
Is it going to be 0?
Yeah, you passed. That's right. So the count is going to start off as 0. So you can see in this React application, what we have is inside of that return statement, we have basically a simple div element, and it's going to print out you've clicked count times, so a variable, you've clicked a variable times, and then it'll have a button below it, and every time you click that button, it'll call the function called setCount, and what it'll do is increment the count by 1. So now I'm going to kind of walk through what would happen in this event. Let's say you click the button. What's happened is the function setCount is called, and count is incremented by 1. What this is going to do is trigger a DOM refresh. React is going to, the DOM is going to be updated, and the web page is going to be re-rendered. So now what you have is every single time you click that button, that count is updated. So that's what's really cool about React is you can have this like dynamic nature very quickly in very few lines of code. And this is an example using that use states. So every single time that value is changed, it's gonna refresh the web page. So I'm gonna pause really quick and take any questions. Is there anyone have any specific questions? Use states, or maybe wants me to explain any aspects of this really quickly.
What's the purpose of like having or the like set counts in like the brackets? When you declare the state variable? Is it like needed every time to have like a second argument thing, or like?
That's a great question. Yeah, so when you're using states, you want to be able to manipulate those states, and you're gonna need to like capture the argument or was it capture the variable to change it. So set count, as I mentioned earlier, it's a function, and we can see the function being called in the button. So how this works is when you call useState, it'll return the variable and then a way to change that variable. And the reason why we need that is you won't be able to change the variable directly. Like, for example, if I wanted to write here count is equal to count plus 1, it would cause an error because it's a constant variable. So you're not allowed to change it directly. Does that kind of answer your question?
Yeah, and the second thing will always be like a setter type function, right?
Absolutely, that's correct. Right. So it'll always come in this pair, and it'll always be a variable and then the function to change that variable. All right, cool. Now I notice I have a question from Sunny. If you want, you can go ahead and unmute yourself or type it in the text.
Hey, can you hear me?
Yes, sir.
Okay. It's a dumb question, but if it's a const, then how come you're able to change the set count? Seems like it increments.
Yeah, that's a fantastic question. Yeah, so it is constant, and you wouldn't be able to modify it directly. This is where the React hook comes in. React provides a means to handle this in the background, and they make it constant on your end. So when you're using it, it's constant to interact with it. But if you like look into the code of the use states, like they have their own way of managing the variable. And like whenever you call the setCount function in the use state code, it'll recognize, okay, we want to change the value of this count, and then we also want to refresh the DOM while we're doing that. Oh, and I should qualify, it only refreshes the DOM if you change the value. So that means if I say set count and I just pass in count by itself, I don't like actually make a change to it, it's not going to refresh the DOM because no action has happened. No work is.
Okay, cool. Thanks.
Yeah, no problem. Thank you for asking thanks for asking questions. And guys, there's seriously no dumb questions. Please feel encouraged. This isn't a super straightforward thing, so like please feel free to ask away if anything comes up. So let's go ahead and hop into the next slide. Now let's talk about React's next hook. This is the second most popular hook, and it's the reason why it's so popular is it adds a cool functionality to your components. Basically, useEffect, what it does is it passes in a callback function, and basically you can use it to program in side effects to occur at the end of each render. So every single time your DOM is refreshed, useEffect would be called, like on my example on the right, every single time the DOM is refreshed, the code inside this useEffect is called. So in this example I have here on the right, you click the button. We already went over this. You click the button, and the count gets incremented. The DOM is refreshed. That little P tag right there, the count in there is incremented. Let's say it starts at 0. After you click the button, the page is refreshed, and it says 1. What we're doing in the useEffect is we're saying now after the DOM is effect, let's also do this side job where I'm going to go ahead and update the title of the document. And if those of you who might not know what that means, the title of a document, or like the title of a document in the DOM, like using like document object model, that's kind of like the web page title. So like when you're on your browser and you have your tabs open, at the very top on the tabs, it'll say something like Google Drives or Google.com, or you know what I'm saying. And that it'll update that title. So now what'll happen in this application is every single time you click the counter, it'll increase it on that little, on the printout, like it'll say in that P tag, it'll have the number increased. And then it'll also update the title of the website to, say you clicked how many times. Now, the useEffect can be expanded. It doesn't only take one argument. You can like add additional arguments to it that are optional. However, I'm not going to get too deep into this, as Shubh will get more into useEffect and how it affects the React lifecycle. He'll cover that content shortly. So moving on, React also allows for custom hooks, and these are really awesome because they enable developers to extract common component logic, things that they find themselves writing a lot, into reusable functions. If you could click. So this provides a mechanism for reusing stateful logic. And I have stateful underlined because you wouldn't make a hook for something that doesn't have, that isn't stateful, that doesn't, maintain its value. So we don't want to get like too into depth because this is a little bit out of the scope of today's workshop. But if you guys are really interested in seeing how these custom hooks work, they're a really great way to, encapsulate some functionality that you're using a lot. These, as with other functions, they should be isolated from any context. So what that means is the code that you want to reuse, it shouldn't have a dependency on a different part of the code. The part you want to isolate, it should be totally independent. It only needs to know its own information. It doesn't need to have any inputs or anything like that. It's totally isolated from its context. And what's really awesome about React is there is extensive free third-party custom hooks that you can download on node.com, like on Node.js. You can find them through the Node package manager. What's really great about React, and you'll see this a lot today, is that there are an extensive developer community that shares their code. So if there's something, like if there's a specific task that you want to add to your code, you don't need to do it yourself. Like check online, see if someone's already doing it already, and you can just install their component and plug it right into your code, no problem. So moving on, I want to go ahead and talk about arrays and objects in JavaScript. So this is not limited to React. I'm speaking in JavaScript in general. And the reason why I bring these up is because arrays and objects are really, really powerful data types that let you group related data under a single container, under a single umbrella. So on the left, I have some simple examples. I have a simple list or a simple array. Many of you guys should be familiar with this. This is just a list of values, 1 through 5. It's a list of integers. Below it, I have a simple JavaScript object. This is also referred to as a map, also referred to as a dictionary. There are many names you'll find in different languages, but essentially what a object is in JavaScript is it is a collection of key value pairs. So on the left, we have a key. This is a unique value. So each key can, if you have like 2 key ones, for example, you'll run into an error because the key is kind of how think about it as like an index in an array. Every index is unique. And then to the right of it, you have the key's value. What's cool about objects is you don't have to limit it to a certain type. Right here I have a pretty complex object. I have my first key, my key 1 is a string. My key 2 has an integer value. My key 3 has an object itself as its value, which has 2 sub values, which key 3a, 3b, and then I also have key 4, which is a list. Now on the right, I have a more practical example how you might use this in your code. Let's say I have like a couple people. Here I have myself, Nykolas. I have the name property, favorite colors property, which is an array of strings, favorite number. I have and then below it I have a second person who has the same properties. And then under that I have an array of people, which is an array of objects. So there's one layer. It's an array of objects. And then below that, I have something called app data. And think about this as like, maybe, for example, I want to contain all my application data into one object. I have an object which has a key, which is a list of people, which, as we looked at a second ago, a list of people, and each person is their own collection of values. And then I also have second key in here called config. And this is a dictionary that has some like config information. Now, the reason why I show you guys this example is I really want to like drive it home, like how complex you can make these things, like how much information you can organize and represent using this object notation. And what's really cool about this is it's very little code to have this like set of attributes and attributes values. I don't know, is anyone here familiar with like object-oriented programming languages like C++ or Java? I don't know if you guys want to like raise your hands. How many people here have used like traditional programming languages? All right, I'm seeing a lot of hands go up. Like I'm sure you guys might remember, recognize in these languages you'll have like I'll say C++ for example. You'll have some sort of like struct name, and then the struct has a bunch of variables and maybe you have some functions there, or you define a class and it has like, that's how you can simulate all this like, grouping of data. But what's really cool about JavaScript or using objects in JavaScript is the notation for this is super straightforward. You just have you just open up your curly braces and you can define these key value pairs very easily. So why are these cool? Well, why do you want to use these? Let's go ahead and move over a slide. So let's take a look at this previous example, and please hold on a moment just before you click. So back from our previous example, we have that yellow bar, which is the entire application, and then we have this green box, which is the product list. How could we represent this in using that JavaScript object notation? How can we represent this using that notation? Basically, I have like this list of objects, essentially, like a list of these products. And every single product has a couple of attributes. So, it has a name, it has a price. It also has like a type, you could say, like, is it a sporting good? Is it an electronic? If you can go ahead and click. So here's what I just mentioned. We have these product objects that have, the price and the name and the type. And then we have a product list, which is a list of products. So let's see what this looks like in JavaScript. You can click, yeah, perfect. So, very simple, using the same notation that I outlined in the previous slide. We have this variable called product list, and this variable is an array of these objects. And in every single object, I have, name, price type, name, price type, name, price type. So what I've created here is like this association of products. Now, I'm just going to go on a slight tangent. Some of you might be wondering, what about can we guarantee that every single object in this list is going to have the same keys? This is something that people say is a detraction from JavaScript, and it's that JavaScript isn't type safe. And what I mean by that is there aren't any rules in JavaScript that define this is going to be an integer. Like in a traditional programming language, you would specify, I have this function, and it's going to receive 2 arguments, an integer and a string. I don't know if you guys have noticed, like throughout looking at this JavaScript code, at no point do I say, like at the very top when I say, let product list equal, I don't say, array of people product list is equal to this, right? I don't have to like qualify and say what the type is. And that's because, JavaScript is softly typed, or, not type safe. And it doesn't like guarantee the types. It basically is implicit. When you write your code, JavaScript will like in real time determine what is the type that you're writing and, kind of figure it out itself. So let's say you have like this like array of objects. And for one of them, like on baseball, I have like, I don't have the price. Like I forgot to type it in there, or I have the key misspelt. This won't cause an error. Like I'm not going to get an error on my code. When I run the code, it's going to run just fine. But what's going to happen is when I'm actually like testing the code out and seeing how it runs, I'm going to get some like pretty fishy behavior. Like I might get like something's not displaying, or I'm getting like maybe a weird warning in the console, and it's not really going to tell me what it means. And the reason for this is, isn't type safe. Now, this can also be an advantage because you don't have to worry, and you don't have to like define, you don't have to like live within guardrails. You can do like pretty cool freeform stuff with your code. But if you guys are interested in like learning more about this, definitely research a popular superset of JavaScript. It's called TypeScript, and it's basically JavaScript but with like type enforcement. Like you can like specify rules and define rules. But anyway, tangent aside, this is an interesting bit of JavaScript you guys might be interested in researching. This is how we could represent this component right here as a list of objects. So we have our list and we have this list of product objects. So let's go ahead and move on to the next slide. Actually, hold on. So what we want to do is figure out how can we transform this list into usable data. So I have this list of information. How can I convert this into like an actual like list of components like we have nicely presented here on the right side? Let's go ahead and take a look at how we can do this transformation. So JavaScript provides, if you want to go ahead and click on the next slide, my bad. JavaScript provides this awesome function already in the house for arrays, and it's called map. And this works for any arrays in JavaScript. And basically what it does is you can use map to perform a segment of code on each element of an array. So for those of you who might be familiar with like in like a traditional programming language, you'll have something like a for each loop. So instead of defining your for loop where you say like int I is equal to 0, I is less than size, and then I++, you can just say something like for each element inside of array. And then what it'll do is it'll iterate through every single element inside that array. Now what map does is it iterates through every single number, like what we call it here. We basically have this function, we say .map, and for each number inside of this array numbers, I want to perform this action. I want to say number times 2. Now, really quickly, I just want to briefly mention some of you guys might be confused about the syntax that I have here. This like parenthesis, number, arrow, then I have like an equal sign, arrow, number times 2. Now, what this is called arrow notation, and it's something that JavaScript. It's a feature of JavaScript, and what it lets you do is write a function in simpler terms, or like in less lines. Traditionally, if I were to write the same thing differently, I could say something like function double number. Like I'll call the function name double number, and then I'll have parentheses, and I'll input my arguments. I'll say like int number, and then I'll have my braces, and I'll say then every time you call this function return number times 2. I have a function that returns number times 2. I can represent that same bit of code just in one line. I can say parentheses number, and what this is these are my input arguments, and then arrow return, basically return what's on the right side. So for every single number, input that number, and then return the number times 2. So that's kind of how arrow notation works. It's not limited to one line. Instead of having like just as written like this, you could put braces after the arrow, and then have like a whole entire block of code that you can work with. Now, this is really cool because it's not just limited to working with arrays. So right here I have this example where I have a array of numbers, and then I go through and double them for this map. This isn't limited to just working with integers. What's really cool is you can use this mapping function to map a list of components, a list of information into React components, into JSX components. So here on the bottom, I have an example of a callback function that for every single number inside of this array, I'm going to go ahead and make a list element and put the number down. This list element is familiar to those of you who know like HTML. This is kind of like a bulleted list. So basically what I'm doing here is for every single number inside of this array, make it a bullet point, like make a bullet point of that number. So this is how you can use it to do an array. So let's go ahead and take a look back go back to our previous example. If you actually go to the next slide. Here, yeah, this is perfect. On the right side, we have that same bit of code, and on the left, I've went ahead and represented what this code would look like if I wanted to do like a for each, right? So at the very top, I have my product. This is a function. This is a React function component. You guys will notice that I'm also using the arrow notation here instead of saying. Another way I could have written this was function product parentheses props, and then those braces. But instead, I choose to use it writing in arrow notation because I think it looks a lot better. And there's some performance differences. If you guys are really curious to learn more about this, I definitely recommend looking this up. But this is JavaScript. This isn't limited to React. So I'm using arrow notation to define this function component for product. And you'll notice that my product receives an object called props as an argument. And my props has some keys to it, which are name and price. And basically what I'm doing is for, to basically make a product, all I'd have to do is call this product function and then pass in this object, which has a name and a price. And what it'll do is it'll print it out. You can kind of see the code here. It prints out the name and then it prints out the price on the right side. Next, I have my product list. This is that green box. And what this product list does is it receives its own list of props. It receives its own props. And what it does is this props object has a value called product list. And what I'm saying is for each product list, so I say product list.map, for each product inside of the product list, I want to make a product component, and I want to pass in that product's information to that component. So some of you guys might be seeing this for the first time, but in React, you can write function components and then reference those components themselves as JSX code. So this is what separates it from HTML. Is you wouldn't do this in HTML. You can't just create your own HTML tag on the fly. Here we created this product object, and now I'm referencing it directly. So think about it like this: for every single product inside of this product list, I'm calling this product component. I'm basically rendering this product component. So if we look at like the HTML code for this page, it's not going to show me like this product. What it's going to show me is a bunch of divs, and every single div has its own name and price, right? So yeah, that's what's going on here. And then I have my product list, and then my product list also has its own printout. It'll go through and it'll print out name and price, the column titles. You can see it in that return statement. And then below it, it'll print out that render, which is what we calculated a second ago when we said for each product and product list, make it a component, and then here we're going to render that entire collection of components. And then below it, we have our app. This is the yellow square. This is that entire, the entire application that's here. And you can see that the app has a state, and inside of the state of this app, we have the product list, which is the array of product lists, and there you can see the name, football, all of that stuff. So I'm gonna pause here for a second because I know there's like a good amount of information here. Is there anything that looks unclear, like the syntax is unclear? Please use this time, ask me any questions, get any clarifications you guys may need. Oh, cool. Ty, I see. I'm not sure if Ha is your first name. Oh, my bad. I see your hand is raised. Did you have a question? Oh, it was probably from the when I was asking who had familiarity with language.
Where does the product come from? Like in the product list render thing, where you have product props equals and product in the curly brackets. Where does like the product come from?
Okay, sure. So the green product, the one that's highlighted green and is like has a
Or
capital
no,
P.
I'll talk about the lowercase one.
Oh, for sure, for sure. So if we take a look at that product list at the very bottom of the page, we have like this array, and inside every single array has its own like has a product. Basically, it's like an object which has name, price, type.
Oh, okay.
Yeah, what we're saying is, so for every single product inside of this list of products, so you kind of see dot map, and then I say product arrow, like that equal sign arrow right there. What I'm saying is, this is basically, think about this as like, the individual product. So that dot map function is going to say for every single product inside of this. So for every single product, and that's the product right there. So that would be an individual.
Okay.
Yeah. And so every single one of these products would contain, three keys, which would be name, price, and type. Exactly.
So it's just an identifier, and like you can name it like anything.
You can name it anything you want. If you have a different list, you can name it whatever you want. And there are some more things you can do. Dot map belongs to JavaScript, so this is a JavaScript thing. So definitely read the documentation if you guys are like interested in like how you can push it, because there's a lot more that I didn't really have time today to like show you guys. But yeah, this dot map function is really cool. But yeah, if you just have one argument in this dot map, it's gonna be like the element itself. So cool. As long as it's the first argument is going to be the element. If you have a second argument, which is optional, it'll be like the index. So if you want to like count through it, it'll be like you can say product, comma, index, and every single you can basically you can reference the index as like as a variable if you need it. Yeah, just something you can do. And yeah, is there any other questions on this slide? And guys, please don't feel bad to ask. There's only good questions. There's no such thing as bad questions. What I mean to say. All right, cool. Assuming my explanation skills are excellent, we shall move on to the next slide. All right, cool. So I want to give you guys some examples of why objects are so great. So you can use objects to seriously simplify data management. So on the left side, I have an example if you didn't want to use objects like in this way. Notice in my product, I have two variables that I'm accepting here. I have a name and a price. And then when I render it, like in that return statement in the product, I say, div name and div price. And like that's kind of cool, right? Like I can reference the variable names directly. I don't need to say something like props.name or any of that. Now let's go to like looking at the product list. We can see my product list has one input, which is the product list itself. And this is cool also because I don't need to say like props.product list or anything like that. I can just reference the product list directly. And here I'm doing the same amount of code. I say, product list.map. And then I say for each product inside of this list, I want to make a product and I want to pass in these two elements. I want to pass in the name and I want to pass in the price. Now, this is where it kind of gets a little cumbersome, right? Because now for every single element I want to pass into this function, I need to individually specify it. Now, if you take a look back at the right side, this is what you guys just saw a moment ago. Basically, I only have one argument that I pass into all my React components, which is props. Oh, and I should really quickly define, this is my choice of a variable name, so you guys can name this variable whatever you want. But what I use props is, it represents properties. So it's like the properties of that component. So you'll notice that the product list props is different from the product props. In product lists, the props contains a list of, the product list variable. So that contains the array of product lists. But what's being passed into the product component is only a subset of the product list. It's an individual product which has the name and price. So basically, what I'm doing is I can like string along these properties very easily under a single object Now for this example you're seeing here, you may be wondering like you get that it's better to use an object, but like this is not that much more code on the left side, like to do them individually, and it looks nicer. However, take into consideration when you start like putting together a React application. I don't even want to say like a big React application, just like a standard sized React application. What you'll find is, let's say you need to make a change. Let's say I need to make a change to this product. Like let's say I want to add a new field to it. Like I want to add type. Now what I have to do is inside of my in my product definition, when I define the React component on top, I have to add it as an argument, comma type. And then I have to go below where I actually go and render it, and then add that as something that I pass in. So I have to rope this together. Now, in a more complicated example, let's say I have like elements that have more layers to them. Like I'm like wiring a property through, all the way. It can get really cumbersome really fast if I have to go through and find all the areas where I pass in the variables and edit a bunch of code in different places. It can get like really difficult to go and make refactors to code. So a great practice here is to use objects to contain related information. Here as the example I've explained to death, I have my product which has its 3 properties. I have this group of related information, the product name, product price, product type, and I group it into an object. And then whenever I want to invoke the render of the product, I just pass it through. Like I don't need to do any funkiness. I can just pass it through directly. So that's like one of the seriously cool advantages of objects. So yeah, here you go. Good example on the right, not so good example on the left. But yeah. So with this being said, I'm gonna go ahead and pass it off to Shubh, and he's gonna take over the second half of this workshop.
Right, guys. So let's talk about what is conditional rendering and how or when you would actually use it. So conditional rendering is a combination of JavaScript mechanism with React components. What this allows you to do is control React components using JavaScript's conditional statements, such as if-else statement or like a switch statement. Think of it as if you like have a Boolean value, which is either true or false, and based on that, you're controlling whether to show a component or not. So if it's a true value, you would actually show a component. If it's a false value, you would not show a component. So for example, if you have an e-commerce store and when you're on the product page and you're doing the price component, you want to think about if there's a sale going on or no. So if there's actually a sale, you would show a lower price than regular, correct? So what you're doing here in the app component here is if you're checking for the Boolean that's on sale. And if that's true, you're showing the $10 price. Otherwise, you're going to show the $20 price. And based on that, the HTML you build, you're going to just return that as a price. Now, what some people say that they actually prefer the conditional rendering part to be inside of their return statement. And so the way you would do that is you would take the template that's the divs outside of it and you would place that in your return statement. And then you would use a shorthand if statement. And what that basically does is checks if it's on sale. So that question mark checks that. And the first one is if that's true, it would output 10. And then the second part is the else statement. So that's going to be the $20. That's just a shorter way to do it. Some people prefer it that way. If you want to keep it longer, you can use the left one. All right. Now let's talk about component lifecycle. So what is component lifecycle and why do you need it? Component lifecycle allows you to run events based on the state of your component. So think of it kind of like an event listener in JavaScript where you have some event happening and you can run your function whenever that event actually happens. So for example, think that you have like a dashboard and in the dashboard, you can add feeds. Now, what you want to do is whenever you add a feed to your dashboard, you actually want to subscribe to that feed, correct? So that if that feed updates, you want to get notifications for it. And similarly, when you remove that feed from your dashboard, you want to unsubscribe from those notifications of that feed. As you can see, this is kind of like running functions when the feed component is added to your dashboard or removed to your dashboard. This is like having an event listener on your component and running the functions whenever the component changes or something happens to it. So how do we actually implement these listeners in React? So to implement these listeners, what you would use is use element hooks. We have already mentioned use effect hook in previous slides, but we'll take a deeper look into how we can use these for our use case. So let's go to the next slide. Here is an example of a mounting component. what mounting component is that you are listening to whenever that component is actually being shown on the in your view. A little bit of expanding on use effect that we previously saw. So you guys know that use effect would run if there is any change in the component. And the second time, or the first time it would actually run is whenever that component is loaded. And then the second time it would run is if there is any change or if the state changes in your component. What React allows us to do is actually control this further by passing in one more parameter into our use effect. So along with the callback function you pass, you can also pass in an array of dependencies. So what this dependencies does is you can have states that you specify in it. So it wouldn't update every time, but it would only update whenever any dependency you have mentioned updates in your component. What we're doing here is we're kind of tricking it to pass no dependencies. So it would only run beginning when your component is actually being shown. And since there are no dependencies, nothing in the array actually updates. So for the rest of its life, it would never gonna run. So that's what that empty array is there for. And whatever you put inside of this use effect is only gonna run whenever you are actually doing the, can you go back one slide? So that subscribe to the feed is only going to run whenever you import that feed into your dashboard. So let's go to the next one. So this slide is actually the opposite of it. So whenever, like we said, that whenever you remove the feed from your dashboard, you actually want to unsubscribe to that feed. So what we want to do is we want to run the function whenever the component is removed. The way to do that is in use effect, there's a callback function, correct? And inside of the callback function, what you can do is actually return a function. What this would do is whenever the component is being taken off or it's being decomposed, this return function would actually run before the removing part happens. And in this part, what we can do is we can do the unsubscribe part. And that's what's going to run right before we take off our feed component from the dashboard. So that's component lifecycles. If you guys have any questions, please unmute yourself.
Yeah, sure. So really quick, we did have a question that was asked in the chat. This one isn't related to lifecycles, but I'm going to answer it really quick. Sunny asked, is there a performance difference between ternary operator and traditional if statements? Just really quick to define for those of you who aren't familiar, ternary operator is that shorthand form that Shubh showed us a moment ago, a couple slides back. Yeah, this thing right here, and it's basically like a one-line if statement. From what I found online and like from what I understand it, there's no fundamental difference between the two. They both represent if-else statements. The only difference comes in terms of like readability. So if you feel like it looks better or it's easier to read, go for ternary operator. But if you have something like a nested if statement, using ternary operator can be more trouble than it's worth. But in terms of performance difference, there isn't anything that's terribly different. It just comes down to personal preference and readability.
Yeah, definitely. All right. Is there any other questions for component lifecycle?
Yeah, actually, and I think we should wait on performance lifecycle a second longer, just because I feel like that's a pretty big concept. What's really cool about what Shubh just showed us is these let you plug into different like lifecycle events of your application, right? Like the first one he showed you, the mounting component, like whenever the component is created, that function is called, and then it is only called when it's created. So let's say you have some special logic that you only want to be called once, you could put it inside that container, and then here if you want to do something when the component is being deleted, at the end of its lifecycle, let's say you want to do some actions there, like the awesome example he gave us. And yeah, so that's what's really cool about life cycles.
Yeah, definitely. And there is a tons of things you can do with the dependencies too. You don't have to run the same logic again. If it's not needed, you only run it whenever you have a dependencies. And guys, you can have multiple of these use effects in your component. There is no limit on that. So if you don't have multiple use effects or multiple dependencies to do stuff for them, you can have that as well.
Right, right. Oh, and I figure just while, and you guys, please feel free to raise your hands or send a message in the chat if you want some, if you feel like I'm interjecting too much for you to get a question in. But I kind of want to expand on what the dependency array does, because it's like a really cool way you can control your use effect. As Shubh like explained really well, you can see here we have an empty dependency array. And what this will do is, only run once, like at the beginning, on mounting. But this is the unmounting example. But yeah, like this will basically tell it only run, one time. And since there's nothing changing, there's no dependencies in here that are changing, it'll basically, be constant. It's not gonna be called more than once. But let's say you have a website and you have you only really want it to refresh the DOM, or you only really want it to do an action when a certain state or a certain component changes, right? You can basically set a series of dependencies like I only want to update the GPA, like what's listed on the GPA, when the number of classes changes. Like I can like listen into like the array of classes that I have. If the array of classes changes, then I want to like update the GPA. But otherwise, there's no reason to run like this bit of code, for example.
Yeah, that's a good example.
Mm-hmm.
Great. I guess we should move on to the next slide.
Yeah, sounds good.
All right, let's talk about APIs. So what is an API? An API, basically in simple terms, is an interface or a method that you use to communicate between two pieces of software. Why would you use an API? You would basically use an API for React whenever you were processing any sensitive information, like processing any payment, or if you want to implement functions that will store or update some data, such as updating like a profile picture or something. You want to do these things not in the React, because whatever code you write in React is actually client facing. That means whenever you do like a control U on any website, you can see the code of the website itself. And so whatever code you write for React, and if you go to your website and do control U, all the code is there. It's just different. It's just a bit of compiled or in some way, but it's all there. So everything you mentioned is viewable to the client. And so if you're processing some sensitive data, you actually want to handle that part in your backend or use a third-party API for that. And to do that, you would actually use an API. So let's see an example of how you would use an API. Here we're using a use effect function hook, to make an API call. So you guys see the fetch function there. So this fetch function takes in a URL, and that URL is the API URL that we're gonna pull the data from. What this API is just gonna give us some random cat pictures, and then we're taking that data returned from it, and we're converting that data into JSON. And once we get that, we're taking that in as a result, and that's going to be console logs. So in simple terms, we're taking cat pictures and we're console logging it into our browser, right? This is a very simple example of what you would do with an API. If you want to do like more advanced stuff, it's really recommended to use libraries such as Axios and GOT, and there's a bunch of more. What they allow you to do, it takes in a lot of boilerplate out of your code, and it would make a lot easier for you to just implement API and request data. Now, there's another level of using these libraries where it comes in like Stripe or Google Spreadsheets. What they do is take this fetching part where you're mentioning the URL and like kind of requesting it. They take that away as well. So what you would do is you would just import that library and just run the functions. And when you run that function, they do all the part of making the request, getting all that. And what they do is do all that and just return you back the data that you need. So this is a very simple example. There's a lot of things you can do with the APIs, and a lot of libraries help you a lot. So it's definitely a big thing you want to check out in terms of APIs. All right, so let's move on and open the floor for questions.
Yeah, that's us. So if you guys have any questions over the entire event, I would like to add some things to the API slide if you actually want to go pop back a second. Yeah, like as you've explained, like there is like a wide range of APIs that you can download that are community made. Kind of like what I mentioned at the very beginning, there is an extensive developer community and a bunch of third-party, free libraries, open source that you can just incorporate right into your own program. Like Shubh said, you might be making calls to an API manually, like the code on the left shows, where you have something like URL and there's like all this, then res to, response to the JSON of the response, and then you do something with it if it all works out. There's API wrappers in a sense that you can download online, and they basically turn this into like objects and functions. So instead of having like the cat API website that you go and reference to, you would just have like cat API object like in your code, and they could just say cat API dot get cat picture, and then it'll return a picture, right? So that's just like one example, like off the top of my head. You can look online, like if you're making API calls to some like common resources, definitely check online to see if there's like an API already built in for like JavaScript that you can just plug into your code as opposed to using it yourself. That's seriously one of the most beautiful things about React and working in Node.js in general, is that the developer community is amazing, and there's like just so many component libraries online. You can put together really, really fantastic professional looking websites with very little effort, very little code on your end, just using third-party extensions and libraries or APIs, stuff like that.
Yeah, definitely. Stripe and Google spreadsheets are just the tip of the iceberg. There's like tons of stuff. Tip
of the iceberg, for real. But yeah, we want to pause and give the floor if any of you guys have any questions on any of the material we covered. You can raise your hand, or you can just unmute yourself, send a text in the chat. Oh, I'm raising my hand. I'm like, oh wait, we gotta volunteer. Does anyone feeling inspired to make their own React application sometime after this? I'm gonna take that as a yes. I'm gonna take that as a silent yes. That's one of the difficulties of running these things online.
They're not gonna tell you their $1 million ideas.
No, I'm gonna tell you. Yeah, exactly. Absolutely.
Hey, could you go over promises real quick?
Oh,
I've seen those, and yeah, I really don't know what they are. To be quite frank with you.
No, that's a really great question. We don't have any material. We didn't really cover this material in the workshop. I don't know, Shubh, if you have like anything you want to speak to that.
Yeah. So you can go back to the API thing. So what we're kind of doing here is kind of like a promise. So whenever you fetch, it takes a little bit of time for you to get back the data. And so when you implement the then part, what it would do is it would wait until the API fetch completes, and then it would run the then part. It's just promising that, hey, I'm gonna get back to you.
Mm-hmm. It's how you kind of have you're basically making a promise that you will have there will be results come back. And what the program will do is, it's asynchronous, so it'll wait for the response comes back, and then once it gets back, you see the .then and then .then.
Oh, so it's like purely like request based, kind of like that.
Mm-hmm. What you can also do is that, let's say you have multiple API calls in one function. What you would do in that case, you would use an async await. And so when you start the function, you would put in async there. And then whenever you run like a fetch, you would do await fetch. And that would basically mean that after, let's say, this fetch, I would have another fetch. It would basically say that don't run the next fetch before I finish this fetch.
I see.
Right.
So you can have multiple. What?
Oh, no, sorry. You go ahead.
So you're gonna have multiple fetches, and you're gonna have multiple await fetch.
Mm-hmm. Yeah. So yeah, and one thing that I kind of noticed, there's React is a library for JavaScript. So while you can go like straight into React and make a React application, it's seriously recommended that you guys spend some time to learn JavaScript. And let me tell you, it's similar to Python in that it is like very it's like a simplified version of a language. It's like kind of simpler than Java or C++. There's like a lot less context there. So it's really recommended that you guys master the basics of JavaScript before you hop into React, because it'll teach you kind of about like the document object model, which is a really big concept in web development, and like how like things are loaded, like when things are loaded, the order that things happen in. So I didn't put this link inside of the useful links and resources, which I kind of kicking myself I didn't. It's a tutorial for like beginner JavaScript tutorial, and it is like seriously comprehensive. Has a lot of the most used like basic components of JavaScript, and shows you like a lot of the cool tools that JavaScript has in it. And also it covers things. It's beginners, but it also covers things such as like async, await promises. Covers concepts such as like mapping and arrow notation. A lot of the ideas that we mentioned today. I put the link in the chat. I seriously like highly recommend this tutorial website if you're trying to learn JavaScript. It got me jump started on the language. So yeah, like you can go straight into React, but definitely make sure you spend some time with the basics.
So I can't see the
much is like, let's say you're developing in React and you're not familiar with this, you might run into some like really basic errors that that will totally confuse you and like set you off, and you'll spend a lot of time trying to debug something that if you had like the understanding ahead of time, it'd be pretty easy.
Yeah, definitely.
I don't know if Shubh or Hasan, you guys have anything you want to add to that?
So, like, I mean, you already know a language very well. So what you want to do is, most of the things in different languages are the same, like if, else statement, variables, functions. You just want to learn the syntax of it in the new language that you're going to, and then just try out a bit and on your own, and then jump into some projects or something to start learning it a bit better. And if you do like simple JavaScript projects, then I think you're set to jump into React.
Yeah, definitely. Those are great points from both of you. If anything, if you're going to be jumping from object-oriented to scripting language, which is JavaScript, object-oriented being C++, more or less work on your data structures. Like sometimes the concepts, more or less, they're similar. So if you can do some data structures based around JavaScript, I mean, you should be good to go, because the HTML and CSS, that'll come to you naturally.
Okay.
Yeah, absolutely. And actually, I don't even know why I forgot to mention that. You don't have to like practice HTML, but I think like from a starting perspective, knowing how HTML works, like being able to like write your own HTML code, it's really basic. Like HTML, like don't get the wrong idea. It's not like an official programming language. It's a markup language is what it's called. And really all you're doing is like defining the building blocks of the website. And you'll be in React. You'll spend a lot of time writing JSX, which is JavaScript, HTML combined together. If you don't understand like the ideas, like the fundamentals of making a web page out of HTML, doing it out of JavaScript is just adding more complexity, and it might be confusing. So definitely just try and understand like the basics, like DOM and like HTML, like those ideas, and then like CSS. Yeah. So basically, like kind of get like an idea for how like vanilla web development works before you hop into React.
All right, cool. Thanks.
Yeah, for sure. Thanks for your question. And Vias put an awesome link. To Free Code Camp. And Free Code Camp is another really seriously great resource. They have for everything. They have walkthroughs for everything. So just to be mindful of everyone's time, let's go ahead and hop into the last few slides. We will be here after the event to answer questions. So if your question wasn't answered, don't worry, we'll still be answering them. But I'm gonna go ahead and pass this to Hasan.
Thanks, man. If anything, let's start wrapping up, and here are a list of some popular Node.js, React libraries that Nykolas, Shubh, and I have used before. Some notable mentions are Material UI. You can use them for things such as buttons and text fields. Nevo is amazing for graphing libraries, and Bootstrap. If you've worked with Bootstrap, React has its own library. They're all available to download via NPM, and the possibilities are endless. Like, you can make projects out of this, and it will definitely be eye-catching to many employers, and they will definitely ask you on what libraries you used or how you made them. So let's go to the next one.
Oh, I have yeah, like with on Hasan's point, like these right here like are just like very tip of the iceberg. These are just a handful of libraries that us here have personally worked with. And I just want to like emphasize Material UI. Some of you guys might recognize that language, Material UI, the Material Design. That's something that Google is like the creators of. It's like this design methodology, for Google buttons and stuff. And someone, like a group of developers, made a open source version of these components that you can just plug right into your program. And then on the right side, we have some like graphing and data visualization, like Nevo and like React Visualized. And like one thing that I'm really trying to emphasize to you guys is, don't waste time styling your own buttons or making your own graphing libraries, right? Because these are like some pretty complicated endeavors. And I mean, unless you're interested in it from like an academic perspective, there's no reason to spend all that time laboring over your own graph element when you can just plug in something like Nevo, which is they have some like really good looking, super dynamic, super reactive graphs that you hover over and it like interacts with you, and super easy to use. Like Material UI has fantastic documentation. So like what I'm trying to emphasize to you guys is look up components. Like when you're putting together your application, don't waste too much time trying to remake the wheel. See what's online and plug it into your application, because it makes your websites look super good, like super clean, with very little effort on your part, very little effort in development time.
Yeah, a bit more on what Nico said. Don't be afraid if you're like a beginner. It's actually a really good thing to use this UI libraries and stuff, because everybody uses it. Just to be honest, like everybody uses
everybody.
So don't be like, if you're a beginner, you cannot use them. These are really simple to use, and these are just some of the examples to start with. But there's like tons more that you can use.
Absolutely. All right, cool.
Sorry about that.
Oh, if you let's go.
All right. Also, make use of the developer tools, guys. Some browsers, they have built-in developer tools that you can use. Chrome, they have many extensions as well, like the React developer tools and React site. They're very useful if you're gonna view subcomponents and components in your React code. And I mean, in general, if you've used Web Inspector and stuff, you can see the actual DOM of the web page, and it pulls it up on the console at the bottom, the web console. So make use of these things, because you can see your code in real time, and should there be any bugs or anything, it'll definitely point it out to you. It'll flag it with like some red icon. I can tell you right now, it's been pretty useful for me, and yeah, it's helped me complete a lot of projects and given me fewer headaches.
Yeah, no, absolutely. Like, guys, developer tools are your friends. Like, they are, like, don't be afraid to use them. Like here we have listed some like good examples. Your browser, a lot of browsers will include some developer tools with it. Like for Google Chrome, if you right click a web page, you can see like an inspect button, and this will open up a whole entire like panel on the right side with like elements on the top, like elements console sources, and you can like look at all of the web page code and then like highlight over every single like like div. For example, we have like a bunch of divs on a website. You can hover over the div, and then it'll highlight on the web page like what you're looking at. So that's just like the built-in tool, and that by itself, like that alone, is like a super cool tool that'll let you slap together front-end displays really easily and like really quickly get insight into your code. But then you can extend this functionality because you can't really inspect the source of a React application, because when you write React code, you're writing code in JavaScript, which is then translated into HTML, which is built into HTML. But you don't write the HTML code yourself. So when you're inspecting the code of a React website, you want to see if there's any extensions available for your browser. here we have some examples for Google Chrome. I think one of these, I think like React Developer Tools is available for Firefox, but yeah, guys, just look into it yourselves. These like let you have some insight into your code. Like for React Developer Tools, we have a screenshot on the top right, and you can see like it'll give you the full component list of your React app, and then you can click on each component and then see like its props, its style information. And this is all in real time. So like, let's say I'm interacting with the web page, this information gets updated with me like as I'm using it. So like React Developer Tools is your best friend when working with React. And then the built-in like Chrome page source tool, as well as like sources and stuff, very, very useful. You'll use them a lot in web development, React or not. So yeah. Oh, and right here, here's those like that compiled list of useful links and resources for you guys if you're looking to get started on your own. Oh yeah, and Hasan said in the chat, feel free to tell us your go-to React library that we might not have mentioned. For any of you guys who have done like web development, maybe not just like limited to React, but like anything. Like if there's anything that you guys really like to use, feel free to drop it in the chat or say something. I'm really curious to see if there's anything we might have missed that you guys enjoyed. But in the meantime, here we've compiled this list of great resources that you guys can use if you're looking to get started yourself. Obviously, first and foremost, the React official documentation. React, like compared to other languages, has some like seriously good documentation. It can be a little bit out of date, but don't let that be a discouragement. As long as you're using a bunch of like resources, you'll be able to like understand what's going on. On the right side, we included a collection of project ideas if you guys are looking to string together some projects to add to your resume. And then below it, I included one of my personal favorite like React application tutorial. This is the one that I use to go from like 0 to like fairly competent in like a month. I'm telling you, React is not too difficult to learn as long as you have like those basics down. Like just find a good YouTube video, a good tutorial, and yeah, you'll be rolling. And then yeah, also there's like a bunch of other great materials. So don't worry, guys. We're gonna send this PowerPoint out, so you guys will be able to click on these links. You don't have to type it out or look it up yourselves.